Thomas Nowak. I am currently working as Vice President, Government Relations and Public Affairs for a Swedish scale-up called Qvantum. If we base the answer on the question on the statement that the technology in principle is ready, then we do indeed need policy innovation and we need social innovation. It could start by a full recognition of the benefits of the technology, including for industrial processes. What we do need is all policymakers understanding it that way. And then, of course, there are some market factors that have an influence. And one is how cheap is the incumbent technology, how cheap it is to operate a fossil combustion process versus a heat pump. And quite often it is, at least in the short-term perspective, cheaper. And industrial processes are often calculated with a very short expectation to the payback period. So that needs to change. It can be changed if electricity, the ratio between electricity and gas prices are significantly reduced. I think a value of 2 about is correct, because then you would be able to compensate for the higher initial investment over the lifetime of the project. For the time being, it seems also relevant and important to still have some subsidies for the initial investments to get the whole engine moving of this transition of the energy system. And then we need to make everybody aware that the technologies that exist. And that's not only the general public or the decision makers in industry, it's also the professors, the universities, the research institutes, so that we also have an inflow of talent into the sector. For sure, if we have a more mass production approach, that would help. At the moment, we are building pretty much every heat pump custom made. So you look at the process, then you go back to the drawing board, then you come up with a test bed, then you test it, then maybe you optimize it, and then it's installed. That is not feasible if you want to decarbonize parts of industry. And mind you that in Europe, the industrial heat demand of below 200 degrees is around 2,000, industrial heat demand is around 2,000 terawatt hours. And depending on the study you're looking at, it's between 35 and 40% of that is in a temperature range up to 200 degrees. So we have a huge amount of energy that we can replace, that we can move from fossil energy input to renewables. So obviously that also means megawatts and gigawatts of installed capacity, and for that we need new players in the market, but we also need the old players to increase their manufacturing capacity. So more standards, more standardized heat pumps would help. At EHPA at that time we have done one project with the paper industry where the clear target was to build a standardized kit, a standardized solution for paper mills. And the result was a 2-stage process with a small heat pump that would bring us a low-pressure steam at 120 degrees, and then a vapor recompression machine that would then bring it up to 180, maybe 200 degrees. So there's already the idea to say, let's take vapor, low-pressure heat pumps, which are now increasingly becoming standard, and let's take quite standardized and quite common vapor recompression technology, merge the two together, and then we have a solution that can be operating at scale. And it can also scale better to the industrial demands, because the vapor recompression is a bit more flexible than the heat pump.